this algorithm takes one vertex at a time. For example, let us assume that it takes a vertex A and then checks for all its adjacent vertices and their distances, the weights. The one which is smallest weight will be taken. That edge will be considered into MST if it is not going to induce any cycle in the MST. Say for example, the second vertex is B. Now we will take all the vertices from both A and B and compare the weights. The vertex which is having the smallest weight, that will be considered in the third step. Let it be, that is C. Now next step we will be taking all the vertices from both A, B and C and compare their weights, and we consider the vertex having minimum weight as the next vertex into the minimum spanning tree. Like this, we go on add vertices to the minimum spanning tree, and the corresponding edges also will be considered. When all the vertices are selected into the minimum spanning tree, we stop this algorithm. However, if we enter into a situation where more than one vertex is having smallest weights, then one of them will select. Like this we will proceed. However, while considering, we should make sure that we will not be having any cycle into the minimum spanning tree. In the following slides, we will try to demonstrate how this algorithm, primsmst algorithm, can be used to find out minimum spanning tree of a graph. Let us consider the graph as shown in the slide. We are considering the node U0. U0 is considered into the minimum spanning tree, and both of its adjacent nodes are selected, and the smallest one will be selected now into the minimum spanning tree. That is the one which is having the minimum distance, that is 5, that will be considered into the minimum spanning tree. By now we have selected the nodes U0 and U1. Then we will try to see all the edges of U0, U1 and their weights. Now we have U3 and U2. U3 is having 10. U2 is having 20 as their weights. Thus, we select the smallest out of them, that is U3, with value weight 10 as another vertex into the minimum spanning tree. And if we verify its inclusion is not going to give any cycle in the minimum spanning tree, thus we retain the same. As of now, we have selected U0, U1, U3 as the vertices into the minimum spanning tree, and then from all these three vertices we check up their adjacents and their weights. Now, out of the remaining nodes, there is two U2, U4, U5. U4 is the one having the minimum distance, that is minimum weight 5. So that will be selected now. If we verify, its inclusion is not going to give any cycle into the graph. Now, with all the 4 selected vertices, we'll check up the unselected vertices and their weights. Incidentally, U2 becomes the vertex having minimum distance, that is 10. That will be considered next, and then U5 will be considered later. For this graph, the final minimum spanning tree is the one having the edges, selected edges, that is U0, U1, U1, U3, U3, U2, U3, U4, and U4, U5. Now let us consider this graph this time. As usual, we are starting from U0. U0 is having all the 4 other vertices as its adjacents. That is U1, U2, U3, and U4. Out of all these things, U3 is having the smallest weight, that is 3. So that will be selected as the next vertex in the minimum spanning tree. As of now, U0, U3, they are the vertices in the minimum spanning tree selected as of now. And from these both vertices, we consider the weights, rather I say smallest weights, with all other remaining nodes. If we compare U1, U2, U4, U2 is the one having smallest weight, that is from U3, that is 2. So thus it will be selected as the next vertex in the minimum spanning tree. Now we consider all the other vertices from both U0, U2, U3, and we find that U1 is having the smallest weight, that is 3. Thus U1 will be considered into the vertex minimum spanning tree. Its inclusion is not going to give any cycle, thus it will be retained into the minimum spanning tree. Then U4 will be automatically considered. Now U4 is also considered into the minimum spanning tree. Now let us consider this graph. The vertex U0 is selected and the same will be considered into the minimum spanning tree. All the adjacent vertices of U0 are now considered. They are U1, U3, U4. Their weights are 4, 8, 11. Thus, the next vertex which we wanted to select will be U1, as it is the one having minimum weight. That is, U1 is selected as the another vertex in the minimum spanning tree. Now we consider all the vertices from both U0 and U1, that is U2, U3, U4 we have taken. They are the adjacents of these two nodes U0, U1. Their weights, when we observe, U3 is the one having the minimum weight. That will be considered the next vertex in the minimum spanning tree. u3 is taken as the another vertex in the minimum spanning tree. Now we consider all the vertices which are adjacent to the nodes, that is cell nodes u0, u1, u3. They are now considered, that is u2, u4, u6, u7. They are selected. Their weights are considered. u2 is having 17 from u1, that is the minimum one, and then u4 11, u6 7, and u7 that is 9. So out of which u6 is the one having minimum weight. Thus that will be selected as the another vertex in the minimum spanning tree. Of course, we have to make sure that by including that we are not going to have any cycle in the graph. So here when we consider u6, we are not going to have any cycle in the graph. Thus u6 is retained into the minimum spanning tree. Thus u6 is selected. This time we are supposed to consider all the adjacents of u1, u0, u3, u6, which are already selected vertices into the minimum spanning tree. The adjacents are u2, u4, u7, u9. Thus, the minimum one, the node which is having minimum is u7, that is 9, that is the minima, that is with the selected node u3. Thus u7 will be the next vertex which will be selected into the minimum spanning tree. Thus u7 is selected into the minimum spanning tree. Inclusion of it is not going to give any cycle. That we can verify. As of now, the selected vertices are u0, u1, u3, u6 and u7. Their adjacents, when we take, they become u2, u4, u5, u8 and u9. Their weights are shown. The minimum of them is 2, that is u8 is having minimum weight with u7. Thus u8 will be selected. Now u8 is selected. Its inclusion is not going to give any cycle in the minimum spanning tree, which we can verify from the graph. Now we select the adjacent nodes of all the selected vertices and their weights. The minimum one will be selected. Now if we verify, u5 is the one having minimum weight. That is from u7, u5 is having minimum weight of 6. That will be considered as the next prosperous vertex into the minimum spanning tree. u5 is selected. Now we consider the adjacents of all the selected vertices and their weights. Now if we verify that u2 is the one having minimum weight, that is with u5. Thus it will be the next prosperous vertex into the minimum spanning tree. u2 is selected. As usual, again we will consider adjacent nodes of all the selected vertices. That is u4 and u9 are the ones which are left over as of now. They are the adjacents of the already selected vertices. If we verify, u4 is having minimum distance 5. that is from U5, and U9 is having a minimum distance of 9, that is with U7. So out of which 5 is a minima. So U4 will be taken as the next vertex into the minimum spanning tree. Also, if we verify, its inclusion is not going to give any cycle in the graph. Thus, U4 is selected. Finally, U9 is also selected. Thus, if we verify the graph, the edges which are marked as blue, they will make up of minimum spanning tree of this graph. You can verify. In the following slides, we include demonstrations about minimum spanning tree calculation using the primsmst algorithm and some other graphs. You can observe. Go through this example also.